Welcome everyone to another edition of Build Hour, our last of the year. My name is Pranav Deshpande. I'm on the product marketing team here at OpenAI, and I'm joined today by my friend Max, who's on the solutions engineering team. And we're going to be talking to you about how you can enhance recommendation systems with LLMs. For those of you who haven't joined Build Hour before, um, little recap on the goal of Build Hour is to empower you with the best practices, tools, and AI expertise to help you scale your company using our APIs and models. And today we're going to show you how you can actually integrate LLMs into different recommendation systems to deliver a better user experience. Just some quick housekeeping before we jump into the content. If you have questions, there's a question and answer functionality in the Zoom webinar, so you can just drop your questions in there. We'll try and answer as many of them as we can during the webinar, but we also have a separate Q&A session at the end of the content. The webinar will be recorded, so you'll get that once we're done here. And then the code that Max is going to use for the demo will also be shared with you once he starts presenting, so you can follow along if you want to. But with that, I'll hand it off to you, Max, to take us in.
Awesome. Thanks, Pranav. So today I'm going to walk through a few different things and just to set a quick agenda. The first, I'm going to talk about LLMs and recommendations more generally, specifically how they kind of play well together and the way we've seen customers and talk to customers about enhancing search and personalized recommendations. We'll then dive into two different examples, do code alongs as well as demos on both what call it contextual understanding. So how do we affect the inputs and as well as explainable recommendations. So how do LLMs interact with like the outputs of a recommendation system? We'll talk about a specific customer example that's seen a lot of success using this type of tactic. We'll then talk about some best practices and considerations as you're starting to build this out. And of course, leave plenty of time for questions and answers. So let's dive into the content and talk about LLMs and recommendations. I think the first thing I want to call out is recommendation systems are not new, right? They've been around for a long time, pretty much as long as everyone's been shopping on the internet or interacting with some sort of marketplace. This is an example from my Amazon account on Black Friday. I share this account with my family, so some of these recommendations aren't super relevant to me, but you get the idea that based on a variety of different things that they know about me, they've surfaced these as potential gift ideas for me. And recommendation systems have been a really good fit for traditional ML for a while. This screenshot I actually grabbed from a blog from Netflix on how they do their recommendation system. And there are many parts here that are driven by more sophisticated ML algorithms, as you can see in that screenshot. But the goal today is to not talk about those. We're focusing more about how LLMs complement and interact with this. So if this is a space where we do have these different techniques in the ML, why use LLMs at all? I'd say there are two primary things that we're talking about here. One is embeddings and nearest neighbor search. There's a cookbook on this topic. We've included that in the resources in the deck. But using semantic search to better understand the user's query and match it to your product catalog. That's something we've seen a lot of success with customers doing. And that's something that's part of this demo, but it's really not the focus of this demo walkthrough. The focus is really more on the right-hand side here, which will be how do we enhance inputs and outputs? Because we've seen that actually being what drives more transformational experiences and has led to some of the more interesting conversations that I've had here at OpenAI. So when I say inputs and outputs, what does that actually mean? And I'd say the way to think about that is thinking about the ways recommendation systems we've seen fall short. And there are two main areas here. The first, on the left-hand side, you can see inputs, so contextual understanding. Sometimes a user searches for something that maybe isn't a great fit for their product catalog. Maybe someone searches, I'm sure some of you maybe have had this experience on websites, search for something and no results pop up, even though there may be some products that are actually relevant to what the user is trying to accomplish. So can we use LLMs to better understand what the end user actually wants, transform the query, and get better results? So more on like the input side of things. For the output side of things, some of these recommendation algorithms and propensity scores, they can be a little bit of a black box where they have a numeric score and a product. But if I'm an end consumer and I see something's recommended to me, like on that screenshot with Amazon, I don't really know why it's recommended to me. It's a little bit unclear. So how can we use LLMs to take the output of that like predicted product and make it more personalized with more approachable language. So we're going to dive into each of these two topics today as part of the code walkthrough as well as the demo. So specifically in those two areas, how we've seen LLMs work well. On the left-hand side for inputs, there's three main things we'll talk about. The first is query expansion. So taking the user's query, expanding it and transforming it to better match the product catalog and drive a more of a personalized search experience. The second bucket there, which is actually related and kind of a subset of the first, I would say, is query augmentation, where not only are we transforming the user's query itself, but we're also injecting information that we know about that user into the query to better drive the results that we're getting from that particular search. And then the last, I already touched on this a little bit, semantic search, but instead of doing something like pure keyword matching, how do we use semantic search to better surface products in your catalog to end users? Then on the right-hand side, this LLM is the last mile. The way to think about that is given the outputs of some sort of traditional recommendation system, I'm sure a lot of you on the call are already doing a lot of this today. How do we use our models as kind of the last step to explain that recommendation to the user in your UI? And this can be done both online and offline, which we can talk about as we go through. Awesome. So these are interesting concepts, but what does this actually look like? Let's take a hypothetical example and see it in action. So for today's prompt, I'd say this is inspired by some real conversations we've had with some of our retail and media customers with similar problems that they face. So this company, OAI Hardware, currently they struggle with some vague searches and users are confused as to why certain products are recommended to them. They're looking at doing a few different things. They want to have their search better match queries to their product catalog and make recommendations more transparent to the user as to why it's specifically relevant to them. So how can we work with them? How can we help them create smarter, more user-friendly recommendations in their product? Let's first talk about the input side of things, so more of like the search experience. And I think when we're thinking about the search experience here, it's important to think about who are our customers and what they're actually trying to do. I'd say this is actually specifically relevant to me because as someone who's tried to do a lot of DIY projects myself, I find myself relying a lot on ChatGPT. But you can see kind of there are a lot of different types of customers, but if we bubble them up here for this hypothetical example, there's two main areas. The DIY pros, people who go into a hardware store and know exactly the things that they need to pick up in order to complete their project. Exactly what type of lumber to pick up, the different fasteners, all the different pieces, they kind of know what they need. They can go in and just buy those products to bring this project to life. On the right-hand side are people more like me, these like quasi DIYers. They know they want to try something. They have an idea of what they're looking to do, but they need some additional help to figure out what they actually need in order to complete the project. Like I mentioned before, I fall in that right-hand bucket, and often I'm using ChatGPT to get some ideas and figure out what are the different types of products that I would need in order to complete a project. So what if we could actually integrate that directly into the shopping experience instead of hopping over to ChatGPT in order to actually get that insight? So let's actually see what this looks like architecturally before we dive into a demo. This is the high-level architecture. You'll see the bottom, I've labeled that as pre-work because we're not actually going to cover that today, but I think it's actually a really important step that we've seen a lot of customers get value out of, where they have some sort of product catalog. In this case, maybe like you can see a product name as well as an image. Maybe you also have some tags or metadata around that product. You can use our models to actually semantically enrich your product catalog and create these semantically rich descriptions that then you can use in a semantic search. So before doing this demo, that's something that we've done already, but I wanted to call it out because I think it's a really important step to enhance that search experience is having good descriptive metadata around your product catalog underneath. What we're actually going to focus more on today is the top part of this, that input side of things, where we have this product data, we have these semantically rich descriptions in a Qdrint database, and we want to talk about how do we take a user's query that's maybe a little bit more ambiguous, maybe more like a goal as opposed to looking for a specific product, using the model to transform that query to a list of relevant categories, as well as a description of those categories and why they're relevant for the user, and then find relevant products using semantic search within those categories, so kind of refining the search even further. So in this example, you can see I need to build a deck, what I need to do, and then getting a response back saying get the perfect boards in order to complete your deck. So this is kind of a very high-level architecture of what this looks like. But now let's actually dive into the code and specifically that top part, and we can see both a demo as well as what this looks like underneath the hood. So I'm going to switch my share here to this second window. Oh. Perfect. So this is just a multi-page Streamlit app, and we'll be actually diving in and looking at what this looks like under the hood. But the first part we're going to focus on is this like semantic search area, where I'm going in and I'm asking some questions. Maybe I have some sort of goal, and I'm looking for a list of different products. A few things I want to call out here before we actually walk through this. This is definitely more of just a demo of the different capabilities. As you're designing your own customer-facing experience, there are a lot of different UI decisions you may make. You're going to see this is like a multi-click search experience, which you might not necessarily want on your website. And we also haven't introduced here any sort of like moderations or guardrails. And that's something that for any sort of customer-facing application is a must. So wanted to kind of set the stage with that before we actually walk through into the demo here. So as I'm logging into this, let's say I have some past purchases that I've purchased from OAI Hardware. Here's that different list, and you as as OAI Hardware, you know this about me and the different things that I've already purchased. So keep that context in mind. And now I have entered this query. And if you go to like our website or you go to an e-commerce website and you search, typically you're kind of searching at the product level. You're searching for a specific type of product. For this type of experience, it's less around a specific product and more like some sort of goal that I have. And how do I get mapped to the right list of products from there? So kind of taking that and transforming it and bringing it to the right level. So I'll type in a query here and say something like, I want to build a deck. Now, this is something, again, personally relevant for me because I'm kind of working on some of these products today. And when I go search these on different websites, I do get like some products that are listed, but no like guidance, no reason why they're listed necessarily. And with this experience, what I'm doing, when I click, I want to build a deck, it's going to expand that query, take in the list of categories coming from my database, and then come up with what are the relevant categories for me as a user in order to complete my project of building a deck. And as I scroll through here, a few different things that I want to call out. One is it's not just recommending things that are tactically like necessary to build a deck, but it also, since the model is smart enough to understand complementary products, it also recommends, oh, hey, you're building a deck, you probably want to furnish that deck. So maybe some patio furniture would be something you're interested in as well. So taking that query, not just helping them complete their project, but also identifying upsell opportunities based on what that user is actually trying to do. The other thing I'll call out here is you'll notice in these descriptions, and we'll dive into this more in the explainable recommendation step, but we're also incorporating some of our past purchases here into this user experience. So the user knows it's kind of complementary based on stuff that I've already purchased in the past. So again, really personalized recommendation to me that combines both what I've purchased in the past as well as the overarching goal that I'm trying to accomplish by doing the search if I want to build a deck. So that's the first piece of this. Again, taking the query, transforming it, and getting it to the right level and to give these sort of personalized recommendations. And then within those different categories, what you can do is do more of a refined, focused semantic search and start to get a little bit more, again, personalized product outputs. So if I'm outdoor patio furniture, let's say I want to focus on, I want to, something I can chill in. So, it's something kind of ambiguous. What does that actually mean? When I click search, you'll see I get some products that look actually more comfortable. Like a hammock's a really good example of that. And if I look in the description of a hammock here, there's nothing that says chill. There's no keyword match on that. But because of how we've described the hammock, and since we're using semantic search and similarity search, the model knows to return that as something that would be interesting to me based on my search. So that just kind of the benefits of semantic search more generally is better understanding the user's query as opposed to just doing a pure keyword match. Now, if I said something like, I'm hosting a dinner party, then the results are a little bit different where now we have something that's, people can kind of sit around this, maybe sit around a fire, have this bistro set. So just an example of kind of the benefits of semantic search there. And I think what's nice about this is because we're doing semantic search directly within a category, we're kind of combining the best of focusing on a specific category, but then having the query be ambiguous or flexible enough to be able to bring in these different types of products. So that's the quick demo of the input side of things. Let's actually see what this looks like under the hood. And I'm going to walk through a few different pieces of the code, but you should also see the repo shared in the chat if you want to follow along there. Awesome. So this is the code under the hood. I'm not going to walk through every single piece of it, but just the parts that I think are particularly relevant. As far as the repo structure, this is just a multi-page Streamlit application that shows kind of the two examples of inputs and outputs. The things to set up yourself and be aware of, there's a config file where you can put in some of your own credentials. It should just work out of the box, but feel free to make any changes there. Some helper functions, that's where we're actually going to be spending most of our time today, where the functions are that kind of drive this experience. The two different pages, the upload to Qgent, that's what we're using to actually house the hardware stored data, the fake hardware stored data here. And then we also have some images generated for that hardware store data that you would just need to unzip. Awesome. So as far as the prereqs here, you can see all you need is Python. You need an OpenAI API key in order to do the semantic search. And then Docker is what we're using to spin up the local Qgent database. Awesome. So you can also see down here the different steps to start to run it. So if you want to run it yourself, feel free to go ahead and do that. But I'm actually going to jump here into the helper function section, and we'll talk about the relevant functions here. And maybe I'll zoom in a little bit to make it easier for folks to see. So on there's a few different things I want to call out here. The first is this past purchases. If you, in the application, you saw I opened up those past purchases, and there's a list of different purchases and what I've had. In this case, I've just had I've hard-coded those. For any of you, obviously, you probably have a database of these different past purchases that you would query for this information. But for this illustrative example, I just have some hard-coded examples for what that purchase history looks like. Those are going to be relevant for both this part as well as the second part we'll get to, which is more like the explainable outputs. So the page one section here is really where we're going to focus some queries. The first is on the kind of query expansion, where we're taking the user's query and matching it to the categories. You'll see I actually have a hard-coded list of those categories. So you would have a list of different categories in your database. And what we're going to do is we're actually using structured outputs to force the model to choose between those categories as opposed to leaving it kind of up to chance. So a good use case here for structured outputs, where we have this different category, we have this different class, and then we're actually using that, creating that list and using it within this expand query with LLM. So I'll open up that expand query with LLM. This is the query that is run when I click I want to build a deck search. And what we're doing is we're combining a few different things. We're passing in what's the user's query. We're also passing in that hard-coded past purchase history. And here's the system prompt itself. Essentially what we're telling it is it's kind of a planner with an access to a product catalog that has a task to do a few different things. One, analyze the user's input and identify relevant categories, which those were things like the building lumber, the patio furniture, etc. Selecting those different relevant categories, and then also crafting engaging descriptions as to why that category was selected. And then only if applicable, mention how the past purchases actually contributed to that selection. So that's why you saw there with the different categories with the descriptions underneath them. They were tying in some of those past purchases that I've had. I then put in some rules there about how it should behave. I do a single shot prompt to give it an example of what that output should look like. And then I pass in those past purchases down here. So that's all it's doing on that kind of first step when I click search. Then once I do that, it returns those different categories. The next is actually doing the semantic search within those categories. And here you can see generate embeddings, pretty straightforward, just using our embeddings model to take the user's query and convert it to an embedding. And then we're using this to actually query the underlying database based on what the user is looking for, using that description that we've created for the product using our vision model ahead of time. And you can see here what we're actually doing is we're using a metadata filter to filter it just on that particular category, so you can get that more targeted search. Cool. So those are the main parts of the application. Again, you go in, do the search, it expands the user's query, it uses the list of categories and structured outputs in order to force it to choose. And then within those categories, it's doing this embedding search to find the right product. So let's actually talk now a little bit about the other option, or not other option, but the other way we've seen LLMs work well with recommendation system, which is on the explainable output side of things. Let me go ahead and switch my share back to the. Oh, yeah, awesome. Cool. So like I said before, we'll talk a little bit more about, instead of on the input side, the output side. I brought this example back up of the explainable recommendations of my screenshot from my Amazon account. I don't really know why these were recommended to me. I just see them in my account, but I'm like, okay, I still don't really get why I have a towel that's specifically useful for me, or why it would be a good gift idea for me. And oh yeah, hardware, they're facing a similar problem where they have a really sophisticated recommendation system that has propensity scores for each item for each user. And these rankings can be shown to the customer, but they feel a bit like a black box. How did they get to that potential number for the propensity score? So what if we could enhance those recommendations by combining them with information about the user to make it more personalized to them and make it more likely that they actually click on that particular item. And for this architecture, again, there's some like pre-work or things that are happening behind the scenes that we're not going to talk about today, which is the right-hand side, where you have some sort of propensity score algorithm that you're using that recommends certain products to a user. And in this case, for simplicity, we just have a product name and what that score is on a per user basis. We'll get into the code. In this case, we're just kind of hard coding that. But I think the key part that we're going to be walking through is the left-hand side here, where we're going to be using our model to take that output, take information about the user, maybe their past purchases, their location, anything you kind of already understand about that user, and then describing that product to the end user and getting them excited about it. So in this example, you can see there's Ember Glow Fire Pit, and the part that's bolded there, I think, is really interesting, where it's taking a past purchase of mine and it's combining that in order to generate or explain why this product was recommended to me. So that would make me more likely to actually click on it because I can understand why it was recommended to me in the first place. Awesome. So now let's dive back into the demo and see what this part looks like. Again, now this is less on the search experience and more on you have some sort of recommendations and you want those explained and more dynamic for the end user. Let me go ahead and switch my share one more time. So this page, pretty simple, but all it is on the top, you can see what are my previous purchases, same previous purchases that I had in page one. And then I have these different recommended products for me. I think one thing to keep in mind with this example, again, not something that would be representative of a real UI where someone's clicking like, tell me why this is recommended to me. This would probably be something that would be kind of generated ahead of time and stored and then just surfaced to the user. And I think the batch API could be a really good way to do that at scale offline. We can talk a little bit about that later. But you can see here are the different recommended products for me and the score and why they're recommended. And when I click on generate explanation, what's going to happen here is it's going